Okay, this tutorial is an introduction into scatter plots in Excel. We're going to talk about how to create them and, more importantly, how to interpret scatter plots once they're created. So let's take a look at the file lemonade stand. Very simple example, simple file with a bunch of numeric data. Remember, scatter plots make sense when we want to look for the relationship between two sets of numeric variables. So if you look in this file, there are a few questions. Let's look at the first question. Do sales tend to be higher when we advertise more? And if so, by how much? This is a pretty common question. Is there a relationship between how much we spend on advertising and how much we sell? All right, look at the columns A, B, C first. These are historical data points for sales, advertising, and temperature in July. Right? So over a number of years, each July we've recorded how much we sold at our little lemonade stand, how much we spent on advertising during that July, and what the average temperature was. All right, so simple data set, just to give an example. 50 data points here, 50 Julys where we've set up our lemonade stand, and every year we've tracked sales, advertising budget, and temperature. So I want to know, looking back at this historical data, is there a relationship between advertising and sales? And if so, do they go together positively? Does more advertising actually help sales, etc.? So if we want to look at the relationship between these two, we can use a scatter plot. First thing we do for a scatter plot is to select the data that we want to put in the scatter. So we're going to take and select the labels as well, sales and advertising. Let's do it this way first. I'll show you a common mistake here when we do this. So I select all of that data, insert, scatter, and just do a scatter plot. Now look what we have here. We've got advertising. Along the x-axis we have sales, and on the y-axis these are the advertising dollars. So basically this is backwards. The x-axis is what you want to use for your prediction, and the y-axis is what you want to predict. So we're not trying to predict advertising budget using sales. We're not trying to figure out how advertising changes as sales change. We want the reverse. We want to predict sales using advertising, right? So we want to say, tell me how much you're spending on advertising, and I'll tell you how much I predict there will be in sales. So we actually did this backwards. We want sales on the y-axis. Your variable of interest, or whatever you're trying to learn more about or learn about the effects on, goes on the y-axis. So we're trying to look at the effects on sales. So let's delete this. Just select it, hit delete. A limitation of base Excel is when it does scatter plots, it takes whatever data is at the right and puts it on the vertical axis, right? So the rightmost column goes on the vertical axis. Since we had July sales to the left and advertising to the right, it put advertising on the vertical axis. So again, more sophisticated packages, you don't have to worry about this. But if you're using the basic Excel, which you can do a lot with, you need to just make sure that whatever you want on the y-axis is to the right in your data. So I can select the entire column A, just click the letter A and I get the entire column. Control C, click the letter D, and hit enter to copy those sales numbers over to D. All I did was copy column A into column D. So now when I do my scatter plots, sales is always going to be furthest to the right. So we'll always put sales on the y-axis. So let's try that scatter plot again. Again, we want to know that relationship between advertising and sales. So let's take all of the advertising data. And now I want to separately select all of the sales data, which is in column D. So I hold down the Control key and I select all of the sales data as well. Now I've got advertising and sales. Now I can go to Insert, Scatter, and now it gives me a scatter plot that looks correct. It has sales on the vertical axis, advertising on the horizontal axis. Now it's not a very pretty scatter plot. I'll agree with you on that because all of the data points seem to be scrunched over here at 50 and up. I can change that pretty easily. If I grab the numbers on the x-axis, right-click, Format Axis, it allows me to specify a minimum and maximum. So it looks like they were all 50 and up, so I'll change that minimum on the x-axis to 50. That looks a little better. So let's take a look at this scatter plot first. So just in a few seconds, we now have a point out here for every point in our data. At one point, we spent this much on advertising and we had this much sales. That's why that point is there. Another year, we spent this much on advertising and sales were this much, and that's why that point is there. So now we have an initial indication if there is any relationship between the two. And if I want to get rid of this label over here, I can just select it and hit delete. So looking at this, it doesn't look like there's much of a relationship, but these dots don't look completely random. They look like they may be tending slightly upwards. In other words, there's none down here in the lower right. There's not a lot up here. So maybe there's a slight trend. So it looks like there may be some relationship. As advertising goes up, sales always go up, but we don't really need to eyeball it. We can actually ask Excel if there is a trend. And I would do this every time you do a scatter plot. Go to the Layout tab, and you see the Trend Line option. Click that and go down to More Trend Line Options. Okay, Layout tab, Trend Line, More Trend Line Options. We're going to put a linear trend line in this. We'll talk about other types later. And see these bottom two check marks? Always check those. You can remove them later if your audience doesn't want to see them, but for you, as you're initially analyzing the data, always see the equation, always see the R-squared value. Click OK. Now let's put this little equation and R-squared value as well as a line. So you see that Excel did pick up some sort of relationship between the two. If this were a completely random cloud of dots, the line would be horizontal. But the line is tending slightly up, so it does look like there's some positive relationship between the two. Again, very simple first cut. We haven't done any statistical significance tests or anything like that. This is just a first cut looking for trends in the data. So it looks like there is a positive relationship between the two. If you look at the question I asked, do sales tend to be higher when we advertise more? We can say that it looks like there is some relationship because there is a positive trend line here. And if so, by how much? That's when this equation becomes very important. Look at the equation. Y equals 5.5x, roughly, minus 53. So what does this mean? In our chart here, y is what's on the y-axis, which is sales. X is whatever's on the horizontal axis, which is advertising. So the way you read this equation is sales equals 5.5 times advertising minus 53. That's a simple little prediction model that says if you tell me how much you're going to spend on advertising, then based on this historical data, I'll tell you how much I would predict in sales. It's the equation of this line. This is the prediction line, right? So if I say, well, I'm thinking about spending $70 on advertising, what would my predicted sales be for this year? It would be 5.5 times 70 minus 53.354. That would be my predicted sales. So now we've done the most simple version of a simple predictive model using this scatter plot. So that's the equation, and it can actually allow me to answer this first question. By displaying this equation, I can answer the question, so do sales tend to be higher when we advertise more? Yes. If so, by how much? By how much is this 5.5 right there, or 5.4798? That's called the size of the effect. Very important concept when you're looking at scatter plots. Yes, there's an effect of advertising on sales, but what is the size of that effect? That's what this 5.5 is. And what that means is for every additional dollar in advertising, for every one increment in X, sales go up by 5.5 or 5.4798. Right? So that's the size of the effect of advertising on sale. It's the slope of this line, right? So now I can say, yes, sales go up when we advertise more, and the size of the effect is for every $1 in advertising that we spend additional, we would expect another $5.48 in sales. Okay? So that's sales and advertising. The next question is, what about temperature? So someone else has a reasonable hypothesis. I bet we sell more lemonade when it's hot outside. Well, I've got a lot of data. I can test that hypothesis. Let's do a scatter plot of average temperature in sales. So again, I just grab all of those data points, including the labels. And since sales are to the right, I know my scatter plot will display correctly. Go to Insert, Scatter. And there's a scatter plot of sales and temperature. Again, looks like there's clearly a trend here. Looks like sales are going up. As we go across this x-axis, it's getting hotter, average temperature Fahrenheit. And as we go up the y-axis, the sales are going up. But again, we don't have to eyeball it. We can go to Trend Line, More Trend Line Options, add a trend line with the equation and the R-squared, and put it right there. And I can get rid of this legend if I want. So now I have another piece of information. Yes, it does seem that sales tend to go up as it gets hotter outside. And what's the size of that effect? 20.633. So look at this equation. Sales equals 20.633 times the temperature outside, Fahrenheit, minus 1579.6. So the size of this effect is 20.633. In other words, for every 1 degree increase in temperature outside, we expect an increase in sales of $20.63. Okay? So that gets to the third question. What's going to have a bigger effect on sales, another dollar in advertising or another degree in temperature? The answer is another degree in temperature. The size of the effect is 20.633 of an increase of 1 in temperature, and it's only 5.4798 for another dollar in advertising. Okay, so those are our 3 questions. One other thing I wanted to mention is I asked you to display the R squared. The R squared really measures, essentially, technically it's the correlation squared. What it measures, if you want to think about it this way, is how closely the dots cluster around the line, right? The more closely the dots are clustered around the line, the more strongly correlated 2 things are, and the R squared is going to be higher. If you look at this temperature sales chart, the dots are much closer to the line, and the R squared is higher, 0.6165 versus 0.4396. The technical definition of the R squared that I want you to be aware of, because it comes up in a lot of context, that's the percentage of the variability in the Y variable that's explained by the X variable. So what I mean is, let's look at advertising and sales. There's a lot of variability in sales, right? Sales go up and down. A lot of things probably explain that. Advertising doesn't explain all of that variability, but what this R square says is advertising spend explains about 44% of the variability in sales. The other variability in sales is explained by other things that aren't in our model, but the R squared gives you a quick understanding of how much of that variability in sales have we understood just by looking at advertising spend. Just by looking at temperature, we've explained about 62% of the variability in sales. Now later in this course we'll get into full regression modeling where we can put multiple predictors in at the same time. But with scatter plots, at least you can do them one at a time, get an understanding of that size of the effect, and get an understanding of the strength of the correlation through that R squared. It's a really great way to start when you have 2 numeric variables and you're trying to assess the relationship between the 2. You'll get a lot more practice out on Blackboard. I'll have several more files for you to walk through and get comfortable with. If you have any questions about scatter plots, or especially about interpreting these diagnostics like the equation, the R squared, please don't hesitate to contact myself or your tutor and we can go through them with you in more detail.